So in this lesson we're going to talk about transforming data. In class today you all should have completed the investigation that covered transformations of data, so some of this should be somewhat familiar if you had success with that investigation. Now you might be wondering, why in the heck would we want to transform data? And the main reason that you would ever want to do this is if you're trying to compare two distributions of data that are similar types of data, but maybe they're in different units. So for instance, on the investigation today, you saw some temperature information given to you in Fahrenheit degrees, but you needed to translate it into a Celsius reading. And that would simply occur in a situation where maybe some readings had been taken with the Fahrenheit temperatures, and then some other readings had been taken in the Celsius temperatures, and you want to compare the two distributions, or the two sets of data. If their units are different, then there's no way that you can really compare those two. You need to convert all of the units of one set of data first so that they're both either in Fahrenheit degrees or both in Celsius degrees, and then you can go about doing the comparisons of the two distributions, talking about the shape, the center, and the spread, like we've been doing. So again, that's the whole reason you'd ever want to transform data, if you're trying to get one set of data into the units of another set of data. But here's how it all works. So here is the basic equation that might describe a transformation. So you might have some old data. Maybe it's not necessarily old, but it's in the units that you're not interested in, and then you're going to transform it into your new set of data that has the units that you're wanting to have. Now, depending on what units you're trying to get to, you might not have to go through both of these pieces, but a transformation could potentially contain two different parts. This B here, this is going to be a change in size. Now, if you remember back to Algebra 2, you should have talked about, and if you were in my class last year, we definitely talked about stretches and shrinks of functions. And if you recall, that happened when we were multiplying a function by a constant. So that's the exact same thing that's happening here. You're just changing the size of your data, so you're either stretching it or shrinking it. You're making it bigger or smaller depending on what your needs are. Then we also have this component here, this A value that we're adding. And this is just going to shift the data either up or down. And again, if you can think back to Algebra 2, we talked about shifting functions up or down, or sometimes left or right, but really here we're just interested in either shifting up if A is positive or shifting down if A is negative. That's all we're talking about in this situation. So let's say that we're going to go through some sort of transformation. We want to know what exactly that's going to do to our data set. So let's talk about our data in terms of the measures of center, and then we'll talk about it in terms of the measures of spread. Now, first of all, let's just refresh our memories. Measures of center are either our mean or our median. Just a really easy way to see how a transformation is going to change the measure of center. I'm just going to sketch out a little curve here, and we're going to see what doing some various transformations would do. So the first thing we're going to do is see what adding a constant to our data would do. So we're going to look at what applying this A value, whatever A might be, to our distribution, what effect that will have. So let's say, here's going to be our two axes. Let's say that here's our original distribution. It looks something like that. And once we get into the chapter about the normal curve, you'll recognize that this is the general shape of a normal curve. So if this is our distribution, you'll notice it's approximately similar, and that means that our mean and our median are going to be approximately the same value. So they'll be about right there. Now, if we decide that we're going to shift our data, either by adding a constant value to all the data points or subtracting a constant value, what that's going to do is simply shift the entire curve. So let's say that that point right there corresponds to our original mean and median. Let's say that we're going to shift our data some positive number of units to the right. So we're going to be adding a positive value. Then that's going to shift the entire curve. So it might now look something like that, which means that our new mean and median is going to be at this point right here. So that's really all adding or subtracting a value to your data points is going to do. It's just going to shift your entire curve left and right. And as you can see, when we applied that shift, that's going to add, we'll just call that A, it's going to either add or subtract that value that you've added to your data points to your mean and your median, which should make some sense. Now let's say that we are going to, instead of adding or subtracting something, we want to multiply our data points by some number. We want to know what is that going to do to our measure of center. Alright, so if we are also going to transform our data set by multiplying by a constant, notice from our equation that means that we are taking all of our old data points, multiplying by some value, and then that's going to transform our data into some new value. So what is that going to do to our measures of center? And it turns out that that does the same thing as addition. It's not that we're adding, this time we're multiplying, but it's also going to have an effect on your measure of center. So if here is our original mean and median, and let's say that instead of multiplying by a value greater than 1, we're going to actually multiply by, let's say, a half. Then what that's going to do is going to take all of our data points, of course, and divide them by half. So it's going to sort of squish out our distribution. So maybe it looks a little bit like that instead. So our peak sort of looks like it's in the same place, but our mean and our median are actually going to be affected by this multiplication as well. So just to review, if we transform our data either by addition or by multiplication, that's going to affect any measure of center, both the mean and the median. Now we need to ask, well, how does the transformation change a measure of spread? Before we talk about that, let's review what our measures of spread are. We can talk about the range as a measure of spread. Remember, we can also talk about the IQR, the interquartile range, as a measure of spread, or we can talk about the standard deviation as a measure of spread. So let's say we talk about this in the same way as we were doing before. So what if we start off with adding a value to our distribution? So here's our original. We're going to add some value A to all of our data points. And that's going to shift our distribution over some number of points. So maybe our peak is now over here. And use your imagination, but these two graphs are supposed to look similar. So here's our new mean and median. We've already said that adding a value to our data is going to change our measures of center, our mean and our median. But it actually, again, you have to use your imagination here a little bit, but it does not affect your measures of spread. Your range, your interquartile range, or your standard deviation are not going to change if you're just shifting the data. And that's because the overall shape of the graph is not going to change at all. It's not going to get any wider or any narrower. It's just moving over a certain number of units. The same is not true, though, if we are going to multiply. The multiplication by some constant on our data set is going to also change our measures of spread. So if this is our original data set and our original distribution, and we multiply by some scalar, let's use the example of 1/2 again. That's going to flatten out our distribution to maybe look like something like this. And you can probably tell that by that flattening out, our range is going to be changed significantly. And you can also see that now the data points are farther away from that mean value, so our standard deviation is also going to be affected as well. So again, just to review these points, for our measures of spread, adding or subtracting a value to our data points is going to have an effect on any measures of spread. If we are multiplying, or excuse me, let me change that. Adding is not going to have an effect on our measures of spread. However, multiplying our data by some constant will have an effect.